despite the title of the presentation that it says it's ONOS Roadmap, we're also going to hijack it a little bit to give you a brief overview of the ONOS architecture and some of the rationale behind its general structure. Now, this is probably old news for most of you, but just in case we have some new attendees or people who are new and unfamiliar with ONOS, this should hopefully provide a base for getting familiar with ONOS. Next, click. I think this is the clicker. I presume so. Yes, it is. So, kind of three base architectural tenets of ONOS are its distributed core, which is required in order to make ONOS a platform for operating mission-critical networks, because we cannot afford any outage. We need to be able to scale, and we need to be able to perform in order to sustain the high demands of control operations that need to be able to be exerted over the network. It is also built around strong abstractions and information models in order to allow applications to be able to both control and configure the network, but also without becoming dependent on device specific. As you probably recall from previous keynote, Mr. Chong mentioned that devices are configured through CLIs, various different models, whether they're Yang or SNMP. So it's a forest out there of wild kingdom of devices, and clearly your applications should not become dependent on the nuances of those individual devices. And this is precisely why we build ONOS with strong abstractions in mind, to allow applications to be written without being codependent on the devices and their nuances. And lastly, ONOS is designed as an applications platform, because we understand that a priori we cannot know all the different applications that you want to, or different use cases that you want to use ONOS for, and so it's designed as an operating system, as a basis for developing additional software to suit your needs. So, as the basis for high-level scalability performance is provided by the ONOS Distributed Applications Platform, which is in itself built on top of OSGI and Apache Karaf. But this is very generic in a sense that it is not tied to networking at all. As a matter of fact, it can be used as a distributed applications platform for anything, not necessarily just network control or network configuration. So what brings the network specifics into play is the, whoops, I pushed the wrong button, is the ONOS networking core. And this is where the various abstractions are defined that make ONOS network specifics. This is where we define notions of traffic selectors, the topology, traffic treatments, flow objectives, and so forth. Now, the ONOS core itself is designed to be as small as possible because we would rather add it through extension, through additions, rather than through subtraction. It's always easier to add stuff than it is to subtract stuff, because then you have to worry about dependencies and things like that. And so ONOS core is designed to be minimal, and the primary responsibility for extending it to fit various use cases needs falls onto ONOS applications. And on ONOS applications, it's a little bit of an overloaded term. The term application here is really more, should be thought of as an extension, because it can fall into many different classes. It can be compiled models, it can be providers, which absorb the differences between protocols, it can be drivers, which absorb differences between devices, and it can be full-on traffic steering applications such as segment routing or VPLS or SDNIP and so forth. And so the ONOS applications are designed to blend in and look as much as the networking core as possible. Now, of course, not necessarily just the volume of the controller is extensible, but also so is its also external surface, which includes user interface, graphical user interface, REST API, gRPC, or other type protocols, northbound protocols can be extended. Of course, so same applies to the command line interface. The idea here is that when you write your application can blend in with the rest of the system so that it is indistinguishable from the core itself, structurally and aesthetically. Now, of course, the networking core itself is not monolithic, even though it often appears on high-level diagrams as a single box. It's in fact comprised of multiple different subsystems. The point of the slide is not to go through the various subsystems, but rather to illustrate the fact that the core itself is very, very modular. And it comprises of components which are network kind of agnostic, domain agnostic, as well as components which are very, very specific to the subject of network control and network configuration. So there's just a little bit of a brief overview of some of the tenets. Now, just there's a brief history here before I hand it over to Yen to talk about roadmap. ONOS, just as a reminder, ONOS released in December 2014, and when we released, it was just this core architecture that I just outlined that came with 4 different applications and support for one southbound plugin, which of course was OpenFlow at the time. But now, 3 years later, we have a platform which has many features and many applications on it. As Guru mentioned, we have now over 125 different apps, which includes various outbound plugins, models, drivers, and so forth. And these clearly provide many different capabilities, and also we offer as part of the core many different distributed primitives for even greater extensibility of the core itself. Now, of course, we did not add this all at once. This was added over a number of releases, and the whole idea here is to show incremental and forward and steady progress, and allow the community to participate in this, but also at the same time to maintain coherence of the architecture and stability and quality of the platform and quality of the code. And so at this point in time, I would like to hand it over to Yen to talk a little bit more about the releases and some of the roadmap items. Ready? Thanks, Yen.
Okay. So ONOS is released in quarterly releases, which means every 3 months we come out with a new release. It started off with Avocet, which was released in December of 2014. And as Thomas has noted, the release was very focused on making sure that the architecture is solid, that the core is modular and is protocol independent. Within the next 3 months, there was a Blackbird release, and the focus on this was to make sure that the performance was improved, it was scaled out and robust. And so what you'll see is for each 3 months, we have additional releases. For example, Cardinal focused around new use cases, Drake, platform enhancements, Imu with Chord. So as many of you are familiar with Chord on our use cases, ONOS is used very prevalently there to enable use cases like our core, being able to deploy AAA applications, DHCP. In March of 2016, we released Falcon, which is the 1.5 release. And here we added dynamic clustering, additional Yang compiler support, and new southbound. So GoldenEye came in 3 months later with some core enhancements and some GUI scaling. There's Hummingbird, Ibis, Junko. We'll catch up to this year. So in Kingfisher, which released in May of 2015, we added Yang tool support, so there's been a lot of interest in dynamic configuration. So what you'll see there is a lot of enhancements to support dynamic configuration and be able to support Yang compilation. In Loon, which we've released very recently, what you'll see there is full Yang.O support, as well as the Yang compiler, which allows you to be able to dynamically load a Yang model and have it be compiled on the run. The other significant changes would be support for OpenConfig model and deprecation of YMS, so that we're fully utilizing the new dynamic configuration systems. And other significant changes there are the core HA enhancements. So there's been a lot of changes in the core and HA space to make it more stable, so that you can run HA more fully. Some really interesting changes that are coming up, and an initial version was released was P4 runtime. So with P4, you're able to dynamically load a new pipeline onto a device, allowing you to support many new use cases. And so recently, we've added support for a control protocol called P4 runtime that the P4 language consortium is in the process of defining as part of their new API working group. Another change we're adding is ISSU. As Guru had noted, we want to get towards deployment, which means we need to make sure that the platform is ready to support use cases like that. And service software upgrade is definitely a significant step towards that. And we've made some changes alluding to provide some initial support for that, especially around portable serialization. In Magpie, which is the release that will be coming up in the November timeframe, we're looking at a lot more changes in ISSU to provide a full protocol support for that, support for the dynamic config store, be able to provide additional support for Yang, so updates to version 1.1, and a device synchronizer in that space that would allow you to essentially realize what you want in terms of configurations on the device. Roadmap. This is a pretty big picture with lots and lots of information. So what you'll see here is in the Loon release, we actually listed out all the things that we provided. So what you'll see in core are the enhancements to the HA framework to make it more stable. And then you'll see in dynamic config the changes we've noted. The open config model support, live Yang compiler. With ISSU, the focus was around making that system ready. So the focus was around portable cryo serialization, so that we can provide forwards and backwards compatibility. We need to make sure that as we deploy upgrades to this system, we're able to communicate and have nodes beyond different versions and be able to talk back and forth and work through consensus. With P4, we've added P4 framework, P4 runtime, which allows you to be able to communicate with the device and be able to update table entries. The focus of our release is around BMD2, which is the behavioral model switch that supports P4. gRPC updates, virtualization, GUI. A big step here was around localization. So what you can do is we've added some internationalization support. You can go into the topology view and get content in Chinese. And with QA, we provided or published a business performance paper, so you can see what our latest performance numbers are. And we've maintained those really well. So with Magpie, which is already released in the November timeframe, you'll see that there is a lot of work planned. So with dynamic configuration, there is a lot of work planned around being able to support per device view into the configuration. So on a per device, you should be able to get the config and set that. We're looking at the configuration synchronizer, Yang 1.1. With ISSU, we're really taking that to the next step in terms of protocol support. So Jordan, our distributed architect, recently provided a proposal around a protocol that would allow us to be very robust in terms of our ability to do rolling upgrades in the system. But you'll see there is, we're going to focus on the core stores. And so we'll focus on making sure that those can be upgraded. As we look at the next release, we're going to move that up to the next level in terms of applications and be able to upgrade those. With the core, what we're looking at is more focus around distribution, right? So we've got a lot of good distributed support in ONOS that we're actually moving out to Atomic so that it can better benefit the rest of the community. And then P4, additional support there around P4 runtime, be able to support groups, device mastership, GNMI support. So what you'll want to do is be able to provide control support for your devices, but also config. And we're looking at GNMI for that, as well as support for open config at that level. gRPC support, GUI, topology 2, and of course, additional localization to make sure that the rest of our community can consume this. QA, a performance paper, a technical version of that, and then we're looking at some enhancements to build-in infrastructure as well as some incubation around P4. We definitely see growth in this area. So what you'll see that we want to explore is VNF offloading to the hardware. be able to better make use of the availability of what's in the switches and be able to offload some of the functionality there. We want to get better telemetry. So we're looking at GNMI as well as INT, which is in-band telemetry, and be able to get better metrics so that administrators can make more intelligent decisions about what they want to do with their network. The P4 fabric, so we want to extend P4 into the fabric so that you can run a fabric that supports both traditional switches as well as P4 enabled switches. ONOS provides great abstraction layers so that your existing applications can run on both types of devices, as well as looking at dynamic program loading. And then we're looking at additional support around virtualization. In N, which is a bit further out, I'll note some quick highlights. With dynamic config sharding and optimization, with ISSU, we want to extend ISSU to the next level and be able to support applications and their custom logic and be able to upgrade those. With P4, rolling the incubation work out to deployment, essentially. gRPC support, and we would be able to search and filter, as well as some additional support around virtualization. So we'll go into these all in a bit more detail in the next few items. So you'll see that these are our near-term, highest priority items. We want to focus on making sure that we have a great dynamic configuration system deployed. So this will be some incremental work to kind of finish that. And then with in-service software upgrade, this is the release where we're really focused on making sure protocol is in place so that you can upgrade your system. P4 integration, P4 runtime, and GNMI gRPC API, scalability, some enhancements around build and release to support our community in terms of their development effort. Virtualization, code basis aggregation to provide more independence to the community in terms of the projects that they're proposing, and federation so that we can better scale out the system. Okay, I'll hand this off to Thomas to cover dynamic configuration since he's been working most closely with that.
Sure, I can quickly do that. This is really not, this is just to describe the effort for the dynamic configuration. This is not necessarily the inventory of work that's being planned ahead. But just in general, I should perhaps correct a little bit of a misconception. It is true that ONOS was behind in support of the Yang toolchain. However, it is not true that we were behind on device configuration because, as a matter of fact, we introduced the device driver subsystem in the Blackbird release, which was our second release, which meant that applications, as of Cardinal release, could start engaging in doing device configurations using the driver mechanism, which provides strong abstractions. And this is something that we still want to maintain going forward. But as part of the sort of the dynamic configuration effort, what we are trying to do is provide a generic core central subsystem in which the device configuration can be tracked on behalf of all devices in the system and on behalf of various services that operators want to deploy in their system. And this will allow the information that is tracked in here will be tracked in one central subsystem rather than what is normally happening in ONOS, where each subsystem has its own separate store where it can distribute the information in accordance with its needs. Now, the approach that ONOS currently uses in this store per subsystem, it allows for much higher performance, because you can take advantage of knowing a priori what the structures look like. But at the same time, it does bring a little bit more higher point of entrance for applications which need to, for application writers, because they need to author their own stores. So with the dynamic configuration subsystem, there's one store which allows the various service and device configurations to be ingested without really writing almost any code a priori. Of course, this is all required. This is all predicated on having adequate toolchain, which is a Yang compiler and Yang runtime. Yang compiler is an entity that's capable of taking raw Yang files and be able to transcribe them effectively into information model that can be digested and manipulated at runtime for both validation and encoding, decoding purposes. It of course requires having somewhere a place to store all of this information, and that's the dynamic configuration store service. And this is, again, as with all subsystems, this is something that needs to support high availability, scalability, and performance, and thus it needs to be distributed across the cluster. And finally, one final piece of the subsystem is ability to be able to actually engage in interacting with outside entities, whether it's orchestrators that lie to the north or whether it's the network elements which lie to the south. And this is done usually through adapters, protocol-specific adapters such as netconf or resconf. And these are basically either southbound or northbound adapters, which operate either in client or server mode, respectively. And you use those specific protocols to be able to then exchange information, which is usually structured in XML or JSON. In case of GNMI, it's actually Google protobufs. Those sort of encodings are used on those external boundaries. And so this is kind of a high-level outline of the dynamic configuration brigade, what they're working on. The specific items for the Magpie release or for the previous Zoom release was something that VM has already mentioned. So I just wanted to provide this high-level overflight over kind of the big picture for the dynamic configuration brigade.
Okay. So what you'll see in terms of the pattern for the next few slides is really kind of the overview of what we're planning to do for each of the features that will be coming out in the upcoming releases. For the in-depth details, you'll want to attend the sessions that will be available tomorrow, where we're going to go more in-depth into, for example, in-service software upgrade. We'll be going into the proposed protocol that we're looking at for the next release. So as in-service software upgrade, what we want to be able to do is provide a system where you have multiple nodes in your cluster. And we do not want to take down all of the nodes to be able to upgrade it. So the intent would be to bring down each individual node, be able to upgrade it and not impact the services in your network. But what that implies is you're going to have a set of nodes in the network that will be running different versions of the software. So how are we going to support rolling that out? So we've done some initial work in Loon to be able to support portable serialization. This would allow us to be able to go forward, go back, be able to remove elements. We're still extending that out. There are some limitations, and I'll cover those in more detail tomorrow. So, please attend the session then. Other things we're looking at is there's the new protocol, which will allow us to be able to look at a multi-phase commit process that would allow us to make sure that if there are issues, we can roll back, which is very critical as we're looking at moving to new firmware. So noted, we need portable serialization to support this. P4. Okay, so with the advent of all the programmable switches and ASICs that are coming out, we see P4 is pretty critical for us to be able to get to that next level with SDN. To be able to provide more programmability in the network and to be able to allow you to be able to customize that network more fully. So what you'll see is the work that we've done. We're going to focus on making sure that programmable pipelines can be pushed down onto these devices. We're looking at a unified control and config mechanism, and this is actually based upon the work that the P4 Language Consortium is doing. They're starting a new API working group, and what they're proposing is the use of P4 runtime as the control mechanism and GNMI using gRPCM as the mechanism to allow you to do configurations on your network. So this is where it gets interesting because traditionally with OpenFlow, for example, you can program your tables and then you can get information like port status, right? Well, here with P4 runtime and GNMI, you're going to see actually an interesting change where you're going to be able to push down your programs via P4 runtime. But you then have to use GNMI to do configuration and basic things like your port status. And so it's an interesting way they're pulling that apart. But of course, this allows both protocols being over gRPC to be much more efficient. We're looking at supporting for both pipeline agnostic and aware applications. As Thomas had noted, there's great abstraction, which means we're able to bring in a lot of these, the support for this on the southbound, which allows abstraction in the northbound to allow you to continue running your applications, to be able to do reactive forwarding, using the existing applications that are there, and then just using drivers that you can put in to be able to support additional devices, whether it's OpenFlow or P4 devices. We're looking at additional things around telemetry. We're hearing that that is critical for providing visibility into the network. GNMI allows support for us through streaming telemetry. You can do it P4 runtime through INTs. So this provides you with band telemetry. You can define custom headers that allow you to pull information and then have it come out as part of your traffic. And then, of course, a P4 fabric. This would allow us to be able to deploy both OpenFlow as well as P4 devices and be able to support them as part of your fabric. gRPC. gRPC is more performant. It allows us to provide more fine-grained access to components within the system. So if you want to be able to deploy applications that are off of the platform, this would provide you with a great opportunity to be able to leverage the functionality that ONOS provides in terms of its visibility into the network, but having a more performant API that allows you to access that information and be able to provide applications in the language of your choice, whether it's Go or Python. It enables you to be able to look at what we have in much more granularity. Okay, UI scalability. Thomas was going to go into this in more detail.
So the UI scalability in here primarily refers to the scalability of the topology view and the ONOS user interface. In the past, or actually, as a matter of fact, even today, the classical topology view provides a flat view of the network, which means it shows you everything, all the information that ONOS currently knows about the network in terms of the devices, lanes, hosts, and various details behind them. But that scales, even though the user interface technology itself is capable of displaying thousands and thousands of devices, the human is actually the weak link here, and the human can't really digest it really easily when it's presented in a single flat view. Looking at a user interface which is speckled with thousands of dots doesn't really provide you with a lot of data, but not with enough information. And so the idea behind the UI scalability is the topology scalability is to actually allow the topology view to be segmented into regions and to be able to zoom in and zoom out of those regions, so that, for example, you can be looking at a high-level overview of the network on a continent, and then you can zoom into a country, into a metro region, down into the center, data center, and potentially down to a specific rack view. And then you can seamlessly zoom in and zoom out across all of these layers. And this allows the person, the operator, to be able to view the information in much more digestible form. And so that's the rationale behind adding some of these UI scalability features. Now, we currently support both the topology, the original topology view, as well as the new topology view. And the reason for supporting both today is because the new topology view has not caught up in terms of all of the functionality with the old one, in terms of supporting overlays, supporting some of the different the user interface features. But it is there for people to start working with and experimenting. And it has been used in a number of different demonstrations in the past few conferences. So the work on this user interface will still continue at least into the M release, if not a little bit into the N release as well. So some of the more details behind behind this is to also add a little bit of some smoother user interactions in terms of being able to customize the different layouts rather than be able to support just a physical geographical layout, which you will often see in demonstrations. The idea is to be able to also support various logical layouts, for example, spine leaf. So you can be able to take the same topology and view it both as a logical spine leaf fabric as well as a physical layout of switches in a data center room or even in a rack. And so the same topology can be viewed in two different ways. Also, be able to support smoother scaling as basically icons that will zoom only so much and then they'll stop scaling as well, or so little and then they'll stop scaling down. We've also revised some of the UI glyphs for various map entities and various buttons to be more visually consistent, and some of that work is still going on. But some of the roadmap items that are further down is to be able to support global search from the user interface. We will provide a search bar and a mast, and you'll be able to type search terms there, and you'll be presented with the results that will allow you to view devices, links, intents, or whatever, really, whatever entity ONOS knows about which matches the search criteria. That's just at a high level some of the user interface enhancements that are planned.
Okay, some additional work that was done was around virtualization. So with virtualization, what you can do is you can essentially create virtual networks, tenant-based virtual networks, and be able to support programmability. So what is different from other virtualization solutions is that what you can do is define a virtual network. You can be able to push flow rules down into it like a normal network. What you're going to see with the virtualization is we're looking at some additional enhancements. So for example, one of the things that we would support is an OF agent. So with the OF agent, what you're able to do is you're able to treat ONOS and its virtual networks as an open flow agent, and on top of it, you can have another controller or other controllers and then be able to treat those networks as just open flow networks and be able to program those. We're looking at some additional functionality that are coming up that would allow you to do a gateway and provide internet connectivity as part of your virtual networks, as well as some additional enhancements there. But the team is still working through getting the rest of the OF agent functionality in place. So recently there was support for LDP as part of what they're adding there, as well as making sure that it's fully fleshed out in terms of the functionality or the programmable functionality that is currently on the ONOS platform. Code base disaggregation. So as you've heard from Samsung, they're looking at contributing a lot of changes that they've been working on to the system. Code-based disaggregation is a way that we can provide independence to projects that are being proposed, so that we can start pulling apart the components within the code base and be able to allow different components to live in their own separate repos. What this ensures is that, as we're rolling out these repos, there can be less centralized reviews of things. This allows the projects to progress at their own pace. Right? So what you can do is Samsung can propose a series of projects. They can go in their repo. You can have your own module owners that are reviewing them independently with, of course, help from the core team. And so what we're doing is we're looking at this in conjunction with some of the build and package work that we're doing to provide infrastructure that would allow this to happen. We're also looking at this in conjunction with other things like, for example, disaggregation of the components within the code base to provide more independent deployment of those. Cluster federation. So we definitely see scale out as being critical to deployment, similar to being able to do as issue. So with cluster federation, what we want to be able to do is have scale out in terms of hierarchical as well as peer-to-peer, right? So what we want to be able to do is build mechanisms that would allow different components in the cluster to be able to communicate with other clusters so that they're able to exchange information, but in a less granular perspective so that they're not all necessarily holding the same state. So we have not started too much work here. There was work on peer-to-peer by Giant, and so this is definitely going to be one of the more future items that we're looking at. So you see a lot of things being presented, and I guess the big question is, how are we going to be able to do all this work? What you saw in Magpie was we had a lot of things on our roadmap. So one of the ways that we're able to do this is we're using brigades. If you look at all the work that we're currently doing, we've got an ISSU brigade that will be starting up soon that we'll be looking for help on. So if you have any sort of knowledge in terms of distributed systems, please come and volunteer and help out there. But what you're seeing is we're leveraging the community in terms of what you can do to be able to help us deliver what we're trying to do. And this is why we're sharing our roadmap, is so that you're aware of what is coming up so that you can leverage it or fully contribute to it. So the brigades that we have in place, we've got dynamic configuration. So a lot of the work that Thomas has been talking about in terms of dynamic configuration, those have been contributed by our community. The virtualization work, Yoon-soon from PostTech has been instrumental in providing that GUI. We have had great contributions from the community to be able to provide better look and feel in our UI, as well as better tooling so that you can get code coverage. gRPC, we have Jen who is graciously leading that and helping us to be able to get the functionality that is currently in ONOS, be able to provide them as protobuf definitions, be able to provide them as services that external applications can leverage to be able to communicate with the devices. Teaching Brigade. The Teaching Brigade has done a lot of work. What you're going to see is the tutorials that are being provided are being contributed by the Teaching Brigade. So please attend those and learn a lot more about ONOS from that. Build and release, we want to make sure that we enable you as the community to develop and contribute to the code base. So we're looking at tooling to make that happen. Northbound Brigade, be able to provide more intent functionality and security and analysis. As we look more fully at deployment, we want to make sure that the system is performant, the system is secure. What you'll see in our releases is that we've actually been handling and getting, this team has been looking at it, submitting security defects, and we've been handling those in a very timely manner. So you'll see updated security advisories on issues that have been recently found. But what this brigade is working on is they're working on the analysis and providing a paper that will be released shortly after ONOS build so that you can better understand the current state of the ONOS system. And then, of course, a major new initiative that we're working on is P4. Right? With the P4 work that we're doing, we're making lots of changes to the system to be able to provide you with support to better program your network. So you'll see support for P4 runtime, but as part of that, significant changes in the system so that you can have gRPC support, and then this way we can leverage it for GNMI as that comes up in the next release. So there is a lot of new work. There's lots of exploratory work that we want to do in this space. So please contribute and feel free to talk to any of the ONOS team members and ONF team members that are here this week if you're interested, especially our community managers, David and William. And they'll get you connected with our brigade leads. So for more information, we have a wiki. We have on the wiki also the roadmap in detail and information on all the brigades. The information for the brigades will contain contact information for the brigades, brigade leads. We make sure that there's Slack channels, Google groups, and so you're welcome to send messages out on that and reach out and connect with the teams. thank the ONOS community for your contributions and, your future contributions. So please help. I think that's all we got.
That was it. Great.
Okay.
All right, thank you so much. Thomas and Yan, thank you so much.